Welcome to Brain Vision.
This section is about using tangent planes to approximate the derivative at a certain point. And so we are given a surface. In this case, it's z is equal to the square root of 9 plus x squared plus y squared. Now we want to find the tangent plane at the point specifically 2, 2, and 5. So to do that, we're going to use the equation of a tangent plane given by the textbook here, which is that z is equal to c plus the partial derivative with respect to x at 2, 2 times x minus 2 plus, I'll take the partial derivative with respect to y at 2, 2 times y minus 2. You may have also seen this written as like z minus c is equal to all that stuff as well if we were to subtract c from both sides. Either one is correct, but sometimes it helps to think of it that way when we have these x minus a, y minus b components here. So really the trick is to figure out these partial derivatives, right? So the partial derivative with respect to x seems like a good enough place to start. So I'm going to rewrite it as 9 plus, and of course I have a typo up here, it's x squared times y squared. So 9 plus x squared y squared to the power of 1/2. And this is what we want to take the partial derivative of, but having the square root always seems like it's easier in this form. So when we take the partial derivative with respect to x, we're going to get 1/2 times 9 plus x squared y squared to the power of negative 1/2. And we'll multiply this by 2y squared times x, because we're treating the y as a constant. I guess you could put this in a different form. Well, so actually the 2 is going to cancel out with the 1/2, right? So these will cancel out, and we are left with y squared over x over 9 plus x squared y squared. And so it's not that hard to figure out then the partial derivative with respect to y, because it's very similar. The only change here is going to be on the numerator, so we get x squared times y. And of course, this should be to the power of 1/2, so over 9 plus x squared y squared to the power of 1/2. Okay, so those are our partial derivatives, which means that if we take partial derivative of x and calculate it at 2, 2, we get 2 squared times 2 over 9 plus 2 squared plus 2 squared. Take the square root of that, which ends up being equal to 8/5. And due to the symmetry of the partial derivative of y, this is also going to be in their values. These are going to be the same. Now, of course, if we had different values for x and y in here, if it was like at 2, 3, we would get different answers, but they made it a little bit simpler for us. So plop everything into our formula, we get z is equal to 5 plus 8/5 times x minus 2 plus 8/5 times y minus 2. And you can do a little bit of algebra, and the result is 8/5 x plus 8/5 y minus 7/5. So that's the plane that we're using, and it'll be up to you to actually plot these using a decent device, but this surface ends up looking something like how do we draw this? Almost like those paper fortunes that you might have. So in the center, it's down, and then all the tips kind of fold up. Then the plane, is gonna slice through one side of it, and then but be above, and then kind of tuck under the other side of it. So if we had a side angle, it might look something more like, so here's our wonky surface, and then the plane is going to do something like that. Yeah, but I do recommend doing the software to get a better idea and do all the zooming in that the problem asks for.